Hello, in this lecture we'll be doing a problem based on the things we have studied till now. Okay, I've drawn the figure and I've also written the question before. This is the question: find the percentage of wood submerged in water if it's still and not sinking or rising. The density of wood is given as 130 kilogram per meter cube. I mean, the density of that particular wooden piece is 130 kilogram meter cube. Okay, sorry, yes, back to a question. Okay, it's given that the density of let me write down another color. The raw of wood is given as 130 kilogram per meter cube, right? Okay, now what can we infer from this? It is given that in still water, not sinking or rising. From that we can infer that the weight or the weight of this wooden piece, let it be Fg, and the buoyant force Fb cancels out, right? Since it's not sinking or rising, it cancels out. Am I right? Okay, so we can say that the Fg is equal to Fb, right? Doesn't sink or rise. Okay, it cancels out. Okay, now let's write down some equations. What is this Fg? Even though it cancels out, what is it? Fg is equal to, you know, the formula for force is volume into density into g, the gravitational constant, V raw g. Okay, we'll write that the volume of Fg is equal to volume of wood into the density of the wood. Oops, sorry. The density of wood into the gravitational constant, right? Now that is Fg. I'll put it in a box. Sorry, wrong tool. Oops. Okay. Yeah, better. Okay, then what is Fb? What is Fb? The buoyant force. We'll have a same equation, but it will be the volume of water. Okay, water. I'll write it as Wa into density of water, Wa into the gravitational constant, right? Now that is the buoyant force. Oops, it always happens. That is the buoyant force. Now what do we have here? We know that Fg is equal to Fb, right? Fg equal to Fb. From where? From here. Those are equal, right? So we can write it as Vw into raw W into G is equal to Vwa into raw Wa into G, right? G goes off. Okay, now we can take these two to the side. Vw by Vwa into raw W. No, we can write it as, sorry, you know, you just take this Vw here and this here equal to raw Wa by raw W, right? Okay, now what is Vw by Vwa? That is what we want, right? Which is equal to density Wa by density W. Now what is density of water? What is the density of water? It is 1000 kilogram per meter cube, right? Now what is density of wood? 130. 130, right? Now I need some space. I'm gonna remove something. We actually need these two. Let's go here. Why is that red? Oops. Okay, better. Now, okay, we have space over here. That's enough. Yes, divided by. Okay, now we get that we can actually. Okay, you know what? You just take the reciprocal of it, so the division becomes very much easy. So volume WA by volume W is equal to 130 by 1000 by 1000, right? You know, I just took the reciprocal of it. This is equal to this, this is equal to this, so this by this equal to this by this. Okay, now we get it as how much? 0.13, right? So that's equal to 13%. You get that the volume of wood is actually 13% of the volume. Sorry, that's actually 13% submerged in water. So we got the answer to this question. I know it's a bit hard to grasp, but that's how you do such problems. Okay, now we have finished that lecture. I mean that problem, sorry. Okay, I'll have to clear this. Take a new one. Don't save. Okay, now since I have some time left, I'll be teaching a new thing, something which you're not familiar of. You might have probably heard about about this thing, flux. Now, what is this flux? Flux of a liquid. Flux is actually the volume by time. Volume by time, where V is equal to volume. Now that is the flux. I don't have anything much to say about flux. Pretty much that's all. Okay, now what to do? Okay, in the next lecture I will be doing another problem. Sorry, another derivation. You know, just like a problem. And after that I'll be talking about Bernoulli's equation. Please do wait till Bernoulli's. Bernoulli's is quite important when it comes to fluid dynamics. Thank you for watching us.